Welcome to the world of data center innovation and the iMasons podcast, discovering the people leading our industry revolution. My name is John Summers, and today I'm joined by Thomas Verghese, Business Development Manager at EnerSys. Tom has an impressive 29 years in the battery industry. EnerSys is an industrial technology leader, supplying backup power to many verticals, including the data center industry. The new EU battery regulation 2023 will have an impact on this industry, on the full life cycle for batteries and waste batteries, from the manufacture through to the end of life recycling, and mandates carbon content declarations, recycled content requirements, performance, durability requirements, removability and replaceability obligations, and also labeling, making the topic very important for everyone using batteries in their critical infrastructure. Now, Tom has agreed to talk to us about how EnerSys is staying ahead of the changes, their efforts in carbon accounting for different battery technologies, and the importance of sustainable design and production of batteries. So let's get right into this now. Well, Tom, thanks. Let's get some questions going then. So, in the energy system, energy systems are very important these days. So, what makes the battery technology come under the spotlight of the moment? What's driving that at the moment?
Yeah, that's a very good question. So fundamentally, batteries have been around as long as electricity's been around, and the lead acid battery was invented in, I think the 1850s by a gentleman called Gaston Planté in France, and batteries have backed up the electricity system and electricity users for the last 150 years. So the batteries have always been there, but they've not necessarily been particularly sexy and exciting. Recently, as we move to decarbonize society, batteries have become more front and center, and they're critical in any efforts that we as a society need to do to back up to decarbonize. One obvious example is the move to electric vehicles, but in addition to that, it's the upgrade of the utility infrastructure, the grid, that needs to be carried out, and batteries are going to be critical as part of that.
That's great. Yeah, that's really, really, really well said. Yeah, and probably people don't realize that batteries are almost everywhere you look these days. There's even the devices that we use on a daily basis. Yeah. So obviously, with climate change and all the things we've been talking about decarbonize, the electrical infrastructure and everything, it's all under review at the moment. So why do we need to talk about carbon content of batteries now? Why do you think it's important that we do this now?
Yeah, so I think for two reasons. If batteries are going to support decarbonisation of the economy, then you have to have an understanding of how much carbon goes into the manufacture and the use of batteries. You can't force people to, for example, use electric vehicles to decarbonise their lives unless you can answer the question. It's overall beneficial in terms of the decarbonisation. So the battery industry is now front and center and has to take responsibility for saying, look, if you use our batteries, then yes, the overall impact will. In addition to that, I think politically, there is this new battery regulation which came out in 2023. Again, I think the EU and our political masters have recognised this, and they recognise that if you're forcing people to decarbonise in whatever way, then they also need to put in place limits to to the carbon that are used for the replacement things that you're putting in place.
Okay, yeah, I mean that's I guess really it boils down to obviously a lot of background work that needs to go into this, because so really could you explain to us what goes into measuring the carbon content of the batteries?
Yeah, so that's a good question, and I think it's an ongoing question for within the industry and even within society. But at a very high level, you can break down your carbon content into three areas: Scope 1, Scope 2, and Scope 3. Scope 1 is your direct carbon emissions, and for a household, that's effectively your gas bill. It's your direct emissions. Scope 2 is your indirect emissions, but at your level. So again, if you go back to the household analogy, that's your electricity bill. You're not producing any carbon by using electricity, but at the other end of the wire, there's a power station that perhaps is producing carbon. So that's your Scope 2 emissions. Scope 3 is the carbon that you perhaps buy in. So it's the supply chain carbon. So for EnerSys as a battery manufacturer, it's the raw materials that we buy in, and it's the carbon associated with the extraction and the refining and the production of those raw materials that we're purchasing from our suppliers.
Yeah, so I guess the scopes of emission, I mean, they're well described by the GHG protocol, aren't they? But it can get a bit confusing because, as a manufacturer, your scopes of emission are different to the end consumer. So it's always good to unravel these things. But maybe before I ask you that question about the scopes of emission, 1, 2, and 3. What are the main learning points that have come out of of calculating the carbon content of the batteries that you're manufacturing or that you're dealing with at the moment?
Yeah. So I think currently where we are is we focus a lot on Scope 1 and Scope 2, and there's a couple of reasons for that. Number one, it's measurable. At a plant level, we have historically had a very good idea of what our Scope 1 and Scope 2 emissions are, because it enables the efficient running of a plant. So even if we weren't looking at carbon emissions, we would still have a very good idea of at the highest level, our gas bill and our electricity bill. Secondly, it's also controllable. So at EnerSys as a company, when we do manufacture product, obviously we're looking to be more efficient, but we also can control those processes and have a good understanding of the gas and electricity and ultimately the carbon associated with the processes within our plant. So we're very much focused at the moment on Scope 1 and Scope 2 and targeting those, including a year-on-year decreases as such. Scope 3 is an interesting one. We clearly are working with our largest suppliers to bring down the carbon associated with our raw materials, but that involves more of a partnership again with our suppliers, particularly the biggest ones.
Oh, okay, yeah, of course, yeah. So in terms of Scope 1 and Scope 2, your Scope 1 and Scope 2 emissions, then they become the users then Scope 3 emissions.
Yeah, so that's a very good point. So effectively, we can, for example, put the Scope 1 and Scope 2 emission of an individual battery or block on the side of on the battery, maybe not today, but in the near future, and then that becomes the Scope 3 associated for a data center. So the data center may have two types of carbon emissions associated with their battery. They have their Scope 3, which is the carbon associated with the manufacture of the battery, plus the data center Scope 2, which is for any UPS system, the battery is effectively permanently on charge. That's how a UPS system works. That's how it maintains the resilience of the data center. So from a data center from our point of view, from a customer's point of view, they need to look at two things: the carbon associated with purchasing of the batteries and the carbon associated with the use of the batteries. And that can be in two ways. Firstly, directly with its use, because you obviously, as I said, keep the battery on charge. But secondly, the carbon associated with the environment around the batteries. And specifically, we're thinking about things like air conditioning here. Batteries, particularly a large string of batteries, need to be kept at a set temperature. That involves an air conditioning unit. And again, air conditioning units use electricity and by extension use carbon. So as soon as you start to dive in, it does get immediately a little bit more complicated.
Yeah, because that's the sort of the operational energy to keep everything running in the data center. Yeah. So, but I mean, in terms of the calculations that you've been doing in terms of the carbon content, what has been the most impact in terms of the carbon content of the batteries? What is the most impactful part of it? Yeah.
So for us, as I say, if we're looking at what we can control, I think there's a couple of areas that we can highlight. One is the move from scope 1 to scope 2. So that, for example, is moving from melting lead to making it smaller in other ways. So again, at the highest level, sawing it to make smaller pellets, as opposed to melting it to make smaller pellets. So that's one example where we've changed a process to reduce our carbon content at the factory level. A second way is just generic increased efficiency at plant levels. That can be anything from increased insulation, replacement of transformers, better lighting, etc., etc. And thirdly, of course, it's looking at where your electricity comes from. So number one, directly, it's solar panels. That would be one obvious example. So clearly, many of our plants now have solar panels on them, which can obviously have a beneficial effect on the carbon emissions associated with the battery production. And secondly, you also have to work with at a larger, almost governmental level, to reduce the carbon associated with your electricity bill. So clearly it varies between countries, but for example, the increase in wind power and the reduction in coal-fired power stations in the UK has had a massive impact on the carbon emissions of our UK factories. And the same in France with their use of nuclear power. That again has had a massive impact on the carbon associated with the electricity associated with the battery production. And again, that can be things like how the robots run in the factory. If you can work at the governmental, wider societal level to reduce your overall carbon associated with per kilowatt hour, that can have a beneficial effect all the way down the supply chain.
Okay, yeah, I mean a little bit on scope 3 again. So for the end user, for the data center, say, and it's good to be able to know what the full scope 3 emissions are. But I guess when you're at the moment only managing to calculate 1, 2, your 1 and 2, your 3 is not included in, or should your 3 be included in the 3 to the end user? This is where things get a little bit more complicated.
Yeah, indeed.
You need raw materials, don't you? And that has an associated emissions with it. So
yeah,
how do you deal with that?
I think the figures that you publish and that you rely on need to be correct. So EnerSys as a company has a global figure for scope 3 that can be found on the website. What we are working towards at the moment is bringing that global figure down to an individual block level. And clearly, we need to be in a position to do that in the near future, as dictated by the battery regulations. And that's something we're working towards. Whereas scope 1 and scope 2, we're probably in a position at the moment to say a block made last year would have serial number XYZ, would have a carbon scope 1, scope 2 content associated with it of and then we can give an exact number, and we can stand by that number, and that number can be audited as well. And I think one of the things that the battery regulation is going to lead to is not only the publication of the carbon associated with the battery, but also how the methodology of that calculation and almost third-party verification of that calculation. All of that is going to come into battery manufacture over the next few years.
Yeah, I think it's not just batteries that need that as well. I think there's a lot of other sectors that will need that kind of scrutiny when you're talking about your scopes of emission, aren't you? So, but I guess you talked a little bit about some of the things that you can do or what you are aiming to do to reduce the carbon content of the batteries. I mean, are there other things that what is your target? What are you going forward for EnerSys? What's
Yeah, so I think by 2040 we're aiming to be zero in terms of scope 1, and then, which is obviously the long-term goal, but I think we're also still looking at year-on-year reductions in both scope 1 and scope 2 as we move towards that goal. So I think it's important to focus on the short-term goals in this case, and that can drive business and investment decisions.
Yeah, okay, and I think, and as you mentioned we mentioned this EU regulation, didn't we, earlier on in and the requirements for product disclosure. So, are you able to explain a little bit more about what that may involve and going forward, and are there pain points that need to be discussed here, or there's anything else that you can add there?
Yeah. So I think for all battery manufacturers, they from this August will be required to CE mark their battery, which will indicate compliance to the new battery regulations. And the battery regulations themselves take a holistic approach. It's very much looking at the circular economy. So it puts requirements on battery manufacturers in terms of where they source their materials. Now, I would argue that most reputable battery manufacturers are probably already doing that, but it's for example, ensuring that many of your materials don't come from areas of conflict within the world, and being able to support that it doesn't contain, for example, nasty materials such as mercury, cadmium. So it does look at the sourcing of the material. It obviously looks at the carbon content associated with the manufacture, as I've discussed. It will define exactly how that carbon is reported. That, I think, is the details are still to be fully worked out on that. But certainly the aim, as I've said, is for every battery to have a carbon content associated with it as a block. And that will be written on the side in the same way you have the voltage and the capacity written on the side of the block at the moment. And then obviously the third part of the circular economy is to have an understanding of what happens to the product at the end of its life. And it's clear that they will have goals in terms of the amount of recycled material that goes into a new battery, and secondly, how much of the batteries that are placed on the market are recycled full stop. Now, one of the things I think we can point to at the moment as part of the lead acid battery, and this is as an industry as a whole, it is possibly or probably the most successfully recycled product in the world, with 99% of batteries placed on the market ultimately being recycled. So there's already a successful recycle stream in place. Fundamentally, that is because a battery at the end of its life, even though it's unable to perform in the way that it was originally designed to do, at the end of its life, it has a value. And that really promotes recycling. That stream is established. And I think from a personal point of view, it's important that recycling stream, which is currently very successful, is maintained. And I think politicians need to ensure that the driving force, which fundamentally is that people make money out of recycling, is maintained within Europe, and it gives Europe its competitive advantage.
Yeah, I think you're right there. I mean, there's a resource efficiency issue here as well. Obviously, we're using material resources. It's not just about energy, but and it's not just about carbon, is it? Because I think you touched upon the points that, climate change is one of the environmental impacts, but there are other environmental impacts that need to be considered. Like eutrophication, acidification, all those kind of things that come out of some of these things like life cycle assessment. But does this new EU battery regulation just focus on carbon, or does it focus on other environmental impacts as well?
So as I said, it certainly focuses on other environmental impacts, including sourcing and having an understanding of where you source the material. And I think you make a good point there, particularly for other chemistries, that you need to be very green and understand your supply chain, I think is perhaps the best way of putting it. But again, I come back to this idea that we also need to reuse the materials, to have an understanding that at the end of their life, it is not sufficient now to effectively export your issues. These old batteries, which in the case of lead acid, contain lead. In the case of other chemistries, contain other chemistries that perhaps you would not want buried at the back of your garden. That those products and the hazards associated with those products are not exported to outside of the EU. That we control what happens to those products within the EU at the end of their life. And in addition, they become useful, that we move towards this circular economy, a sustainable economy, so that we're not, as you say, just taking material out the ground, assuming it's an infinite resource, because clearly it isn't, and that goes across all chemistries.
Yeah, I think that's very important for pushing for recycling of some of these materials and keeping them within the EU jurisdiction. So I said, so they can be. When you talked about recycling, a lot of things could be recycled. I mean, I've heard a lot about lithium being a difficult material to recycle. I don't know whether that's something you can say anything about, because I guess some people listening to this will notice some discussion points on lithium being a terrible substance, but also very, very important to the battery technology.
Yeah. So, I mean, certainly lithium as a technology is going to be critical. It's going to create, it is creating its own new markets, and it's going to be absolutely critical as we move towards, a more resilient grid, as well as obviously electric vehicles. And it is here already, phones, computers, etc., etc. So lithium technology is with us as we speak. We do need to get better at reusing it, at recycling it. I think there are a number of initiatives around that at the moment. I think it's difficult to say for certain. Again, my personal opinion is that the cost associated with disposal and recycling of lithium will certainly start to come down, particularly as the batteries associated with electric vehicles start to reach their end of life. And clearly, in that sort of market, you're looking at second life as well. So your first life might, for example, be electric vehicles. At some point, the battery may not be suitable for that sort of application anymore, and then it becomes an issue of, okay, this energy storage device still has advantages, and we can use that in another environment. And I think cleverer people than me are working towards that at the moment. One of the things that you need to have an understanding of, though, is at an individual level for the battery, you need to have a history of an EV battery. Almost, has it been in a crash, for example? And I think there is articles within the battery regulations around what's called a battery passport, which will allow the end user or the battery to basically report on its history, on its own history through its life, and that will promote particularly second use.
That's really interesting, because I'm working on other projects where we're talking about second life, particularly second life of microelectronics as well, because the electronic waste industry is growing phenomenally, and it's I think it's a good discussion point, being able to understand the traceability of the components that are now going into second life. It's a bit like an odometer on a vehicle, isn't it? When you sell the vehicle, you shouldn't really change the mileage it's done, but it is historical. It'd be interesting to see how this pans out, whether this is a blockchain technology that we use or something like that, to digitalize it. I think there's some interesting things that could happen in this space. Yeah,
there's clearly an overlap there between particularly lithium batteries and the electronics industry. They share a lot of the same challenges, shall we say? So I think, I think it's certainly something that is being driven politically, but has obvious advantages to society and end users.
Oh yes, that's great. Yeah, I mean, what thinking about the data center as the end user again, what do you think are the key takeaways of what's happening now for the data center owners and operators? Would they make decisions, if there is this passporting or this disclosure, will they make decisions based on, that battery has less carbon in it in its manufacture, I'm going to buy those batteries, and will they be more expensive than the one that has more carbon in it? That kind of, when does that discussion start to happen, and what do you think will happen from the data center perspective?
That's an excellent question. I think data centers, particularly as we move towards larger and larger and fundamentally more energy requirements within the data center, and indeed as data centers start to take up more of a nation's energy production, an increased spotlight will be put on how efficient data centers are, both at one level and as a whole, across Europe. And there may, I don't know, but there may be sort of tax implications in order to encourage data centers to become more efficient. So overall, fundamentally, the electricity bill of a data center is likely to increase, and AI, to my understanding, is also likely to contribute to that. So data centers, I think, regardless, will start to look at becoming more efficient. That's already happening, and will continue, is a trend that will continue to happen after that. And the use of batteries is going to be part of that story. Now, I think it's fundamental to remember that the batteries are there to promote resilience within the data center. So while we can look at things like low carbon use within the data center, it's important to remember that the battery needs to do what it may be called on to do on an occasional basis. Recent events have indicated the importance of data centers to society, and it's only going to become more and more important. So fundamentally, yes, the battery needs to work. That's the first thing. The second thing is that not all batteries are created equal, both in terms of, as we said, the carbon associated with their manufacture, their transport from wherever they're manufactured. And so it's important for the data centers to look at that and to almost assign a value to that. So again, we're not saying that a level below which isn't acceptable, but there must be a point where it is worth, even for buying in carbon in terms of the battery, there must be a value to paying a little bit more for a lower carbon product, for example. And then thirdly, as I think I discussed right at the beginning, if the batteries are able to run with less electricity while maintaining that resilience, which is critical to the running of the data center, if they're able to maintain that resilience, then again, that must have a value to the data center. And that can either be, for example, in terms of the float current that the batteries draw, and certainly more advanced lead acid technologies, for example, that EnerSys produce, do lead to less electricity associated with float voltages. And also data centers may take the view that they need to look at some of their cooling circuits, and I'm sure they're doing that anyway.
Yeah, I think I mean the energy efficiency of data centers has been a topic of great interest, and it's becoming more and more poignant now with the growth of AI and these data centers consuming a lot of energy. But the discussion about scope 3 is also gaining traction within the data center, and I think the disclosure that you talked about will only help data centers be able to report that scope 3, but it's not just the batteries. It needs to be across all of the infrastructure that goes into a data center so that they can accurately report that. But before we finish, Tom, I mean, if people who want to find out more, I mean, obviously we've only touched the tip of the iceberg here with the scopes of emission and the battery regulations that's come in line. Where can people find out more information?
Yeah, so ironically, since we've been talking about data centers, I would suggest a well-known search engine as being your first point of call. The battery regulation is on the EU website. It's 2023-1542 for those interested. The EnerSys website has its own sustainability area. So if anybody's interested in EnerSys' specific goals. And target, and there are a large, and there are a large number of external companies who are giving overviews of the battery regulation at the moment.
Well, that's fantastic. Thanks so much for the coming onto the podcast today. Yeah, thanks a lot, Tom. Yeah,
it was a pleasure. Thank you.